Well, good morning, everyone. Thank you very much for coming to today's webinar on upcoming DER integration standards and operational impacts for DERs. We're very happy that you are joining us, and thank you for taking time to be here. My name is Graham Samari, and I'll be your moderator for today's session. Without further ado, I'm pleased to introduce our speaker, Advanced Power Systems Engineer, Dr. Keaton Wheeler. He will guide us through the latest developments and the future of those developments. Take it away, Keaton.
Thanks, Graham. Thanks all for attending. So as Graham mentioned, this is for upcoming DR integration standards and operational impacts. So we're just going to be going through two proposed changes, or one's more of a rollout, and then the other one is an actual proposed change to the standard that we're soliciting feedback for. So without further ado, for an outline, first thing I'm going to do is I'm going to talk about kind of what we're experiencing at FortisAlberta in terms of DERs. I'm going to go through a little bit on the control modes update, and I'm going to go through what our rollout plan looks like. I'm also going to go through EMT modeling updates and also the rollout associated to that. So again, looking for feedback on all this. Now, I will caveat this that there will be a question and answer period after the presentation. The presentation itself will not be too long, and we'll just be having a conversation at the end of this. Okay, so from a DER perspective, FortisAlberta has roughly 1.3 gigawatts of installed DERs on its network. Now, 1.2 gigawatts of that is DG, and 163 megawatts is MGs. Again, they're all distribution connected. Now, just to put it in perspective, the total DERs that were installed in Alberta in 2024, cumulatively, was 2.1 gigawatts, and that accounts for we account for about 62% of that. Now, to put it in perspective relative to load, FortisAlberta only services 28% of the load for the whole province, and we only service 12% of the population, relatively speaking. So our DER penetration relative to our service area is extremely high. So this is why we're experiencing so many challenges. I have put a few graphs up here, just showing how often we're getting these things in and what our install capacities are each year. And you can see, generally speaking, we're seeing exponential increases, in particular with MGs at the moment. But again, very, very high penetration levels. Very common for us to see substations that now have 60 megawatts and above on them. So it's creating some very significant operational challenges. And this leads us into advanced DER control modes. Now, right now, what FortisAlberta requires is constant power factor for all DERs. Now, this is MG and DG sites. So this mode does not react to system conditions or really make corrections. So voltages move, these DERs don't really react per se to try and correct that. To help mitigate some of our nuisance tripping issues and enhance our overall system stability, we're moving ourselves off to advanced DER control. Now, this is a combination of Volt-Var, Volt-Watt, Watt-Var, and constant power factor. So these are the modes that we're going to be employing going forward. And this includes some of the older generators that are in our network right now. So again, I have put up some figures here, which are from IEEE 1547, 2018, that kind of represent what those curves look like. Now, there's obviously going to be a lot of questions on this, which is why I will try and answer a few of these as we're going. Now, we have started looking at this for a while now. So originally what we were doing is we were conducting a pilot using Volt-Var for 2 DER sites. Now, the range of these sites was 10 to 25 megawatts, and they were both near a substation, and they were connected on the same substation transformer. Now, this project was conducted through our DER planning team, and I can give you some of the key results from that. First off, the voltage profile on the feeders where the Volt-Var was enabled was significantly more stable. We saw substation regulator operations reduced by roughly 60% when the DERs were in Volt-Var, and that was in a comparison to their previous year when they were in constant power factor. Similarly, what we saw was distribution tapper operations were reduced by about 80%, so significant reductions there. The sites that have Volt-Var enabled, they haven't seen any nuisance trips since that control mode was enabled. Now, The interesting thing about this particular location is on an adjacent feeder, where the same substation but a different substation transformer, we are still seeing nuisance stripping problems for those sites, even though they're at the same, essentially the same location. So again, another reason why we're going down this path. So although the power factor and active power output under Volt-Var mode was slightly lower than the fixed power factor mode, Volt-Var mode has the potential to keep the voltage in the acceptable range, meaning that we were avoiding overvoltage trips. So as a result of that, we found that the net revenue from these particular projects had negligible impact. So the actual number is about 0.4% higher than when they were in fixed power factor mode. But the point is that it wasn't a major issue. Now, we did have some ratchet problems originally when we first started this, but that was boiled down to an inverter malfunction, which caused the reactive power absorption to go well beyond 90% power factor leading. So that's where the ratchet issue happened with that. But once that was corrected, we didn't experience any more ratchet problems. Yeah, that's from the pilot. So we do have some common questions that will come up associated to this. One of the common questions is, again, ratchets. I know that ratchets is an issue for a lot of DG customers. And one of the issues is, will the ratchet charges go up? Now, what I can tell you is that billing is determined on the average of the 15-minute interval demand values for both kilowatt and kVA within a given month. So with the ratchet being set at 90% of the same highest metered kilowatt per kVA demand in the past 12-month period, including and ending with the billing period. So essentially what this means is if you see a slight overshoot, so if let's say, for example, you need to be at 90% power factor and you overshoot and you hit 89 for a few seconds, you're not going to see that on a ratchet charge. So basically, if this is set up correctly, when you're in Volt-Var or in one of the other modes, if you've done this correctly and you do not go outside that 90% bound, you're not expected to see a ratchet problem. Okay. The other question that we get is will my revenue be impacted? Now, if the site's currently on constant power factor mode, they're absorbing large amounts of reactive power. The revenue is probably going to increase. It may increase in those cases. But again, based on our pilot results, we're not expecting to see greatly affected. Okay. And the reason for that is because unity power factor is going to happen more often. Now, so you have increased uptime, hence your revenues tend to, if anything, go up. But again, we're talking negligible changes here. Settings. So what settings will be used here? So now, obviously, there's default settings in IEEE 1547. There's other default settings in other standards as well. The control mode set points are going to be provided by FortisAlberta for the DER, and the DER will be responsible for implementing these settings. Now, these set points are determined by studies that are conducted by our in-house engineering team. But generally speaking, what you'll see is for sites near the substation, Volt-Var with Volt-Watt will typically be used. And for sites further down the line, you're going to see any combination of Volt-Var with Volt-Watt, Watt-Var with Volt-Watt, and constant power factor with Volt-Watt. Now, again, this is based on studies and it's based on the system conditions. So each one of these is based on a specific site location. Last question is legacy equipment. Will it be treated differently? The short answer to this is yes, but I'm going to give you more details further in this presentation. Okay, so rollout criteria will be used for the initial 4 phases rollout. So any new DER, MG or DG with a project nameplate rating of 150 kilowatts and above, you're going to get this right away. We're going to start putting these into our detail level studies, and these set points are going to be there. Again, there is caveats associated to this. Again, if you pass like a 110-day package, we're not going to go in there and make those changes. Existing DERs with a total nameplate rating of 500 kVA and above, you're going to be caught up in this as well. So anything that's above 500 will be part of this. Excuse me. It is intended to eventually reach all DER projects, where we include small MGs, including like residential sites and stuff like that, but they're not going to be part of this specific rollout. And they're going to be part of a completely separate process, and that has not been defined yet. Now, in terms of ratchet charges, if a large amount of consumption occurs that does trigger an unexpected ratchet, then you contact your stakeholder relations manager. These will be reviewed on a case-by-case basis, and actions will be determined at FortisAlberta's sole discretion. But if you're in a testing phase as well, please make sure you notify us in advance so that we can take all of that into consideration. Okay. Okay. So for rollout applicability, now we're going to talk about what's considered legacy and not. So legacy DERs are considered to be connected prior to January 2020. That's the cutoff that we're using. I will include here FortisAlberta's DER2, which is our interconnection standard associated to these. We had IEEE 1547/2018 as a normative reference in January of 2019. So we've given an extra year. All DRs connected after this were required to have the advanced control functions available and already tested during commissioning. So timelines and applicability of required control modes are going to be considered based on the DER connection date. So for non-legacy DERs, that's anything that is January 2020. You're going to get a 60-day notice with what the control mode step points are going to be and what those control modes are. And this is just more typical. And then we'll also provide a contact on who you need to talk to for implementation. Now, once those are implemented, you'll notify FortisAlberta that they're implemented, and then we'll track that as well. For legacy DERs, so these are the ones that are a little older, we're going to work directly with the DER on reasonable timelines for implementation if required. Now, legacy DERs are only going to be asked to put in these control modes if we have one of two things happen. One, the DER requests to go into those control modes, or we see a system operations problem and we determine that we really need to do this. But these are going to be case by case, and the rollout may only affect specific legacy DERs. Again, these ones, there's a lot more leeway here. We're going to be working directly with you on this. We are going to be asking for feedback on the rollout plan. So details on where you can provide that feedback is going to be given at the end of this presentation. So please be patient on that front. Okay. I think that looks okay for now. Yeah. Okay. Cool. All right. EMT modeling and EMT and DR modeling and EMT requirements. Okay. So as I've mentioned before, we're experiencing very high levels of DR penetration in the network. So as a result, our need to model the system in greater detail and employ more advanced techniques to manage the system safely and reliably is becoming more pressing. For sites where electromagnetic transient models are required, current requirements for inverter-based resources, we're asking for unit-level OEM models of the specific inverter. The issue with this approach is that when we're dealing with composite sites, so this is everything that's 500 kVA essentially and above, that employ power plant controllers, they affect the performance and behavior of the DER plant. So the result is that the system level studies with a unit level model may be inaccurate, which may lead to unnecessary mitigations. So for now, we've only ever requested EMT models related to inverter-based resources. We may need to go down the path of asking for synchronous generators in the future. Again, that we're not asking for that right now. But again, that is why we've also extended this invite to and this engagement to proponents utilizing synchronous generation and induction generator types as well. So from this, what we're looking for is we're looking to employ a modified version of ISO rule 503.21. These changes will be reflected in our interconnection standards, okay? All right, so the proposed changes that we're dealing with is we're looking at requiring plant level models that are validated for any DER that is 500 kVA and above. Okay, so this is predominantly inverter based for now. Again, synchronous machines are not caught up in this right now, but we're asking for anything that's composite. So essentially there's a power plant controller and that's the reason why we're asking for this. If it's less than 500 kVA, but it is high gen to load ratio, we're also going to be asking for a validated plant model. And if it's 150 kilowatts to 500 kVA, but it's a medium or a low ratio site, we're talking generation to load ratio again, then the OEM or the aggregated model will be what we're looking for. Again, this is a draft. This is not enforced right now. We haven't rolled it into the standards, and we're still soliciting feedback on this. We are targeting to roll this one into Q1, Q2 of 2026. And again, this is due to our high DER saturation challenges, which we are experiencing many of them. This slide, I'm giving some of the draft language that we are looking for. Again, it's pretty much a rehash of what the previous slide was. It's just got a little bit more detail here. Where we came up with the 500 kVA number is taken directly out of IEEE 1547/2018. Again, this is generally an accepted threshold for a delineation between small scale DER and what we call larger scale. And this is usually where composites start to come into play. Now, the 150 kilowatt threshold has been taken from the delineation between large and small microgeneration. That's why. And you can also notice as well in our DER standards in general, we delineate small and large at 150 kilowatts. So that's kind of where this is coming from. Okay. So for next steps, what we are going to be doing is we're going to be putting out a bulletin, and we'll be putting out this recording as well onto our website. We are requesting written feedback by December 5th of this year. I've given the email address here, generation@FortisAlberta.com, and a specific subject line we would like to be used, if at all possible. The feedback that we're looking for is the control modes. We're looking for the rollout specifically, any concerns proponents may have. EMT as well, we're looking for feedback on these requirements. And we're actually also looking for requirements on the webinar too. This is the first webinar of its kind for FortisAlberta. So we're asking for feedback on the format and any other items related to it. So please address those all in the written feedback as best as you can. I'm also requesting that you provide supporting evidence for your feedback wherever possible. This just allows us to facilitate further consideration for potential revisions of this. If there are specific questions, comments, or concerns or verbal feedback, please reach out to your designated stakeholder relations manager. But again, we are going to leave some time today as well for questions and all that kind of stuff. So I'm just going to, so at that point, I guess that's a good segue into saying I'm free now for questions. So I'm going to kind of tag team now with Graham on the Q&A piece here.
Thank you, Keaton. And yeah, we can get into the Q&A portion of the webinar. So 2 ways to do it. We do have the Q&A option open in Teams, so you can go ahead and send written questions there, or just also raise a hand, and I'll virtually come by and unmute your mic, and yeah, we can have that open discussion. I see you there, Laura. You are first. Go ahead. And if you could, another just consideration with the whole team, if you could start with name and affiliation, that would be great. Oh, where did you go? Oh, I think, Laura, did you put your hand down? Did you mean to do that? Yeah, I saw you there first, Laura. I'll get to you next. But go ahead, Laura.
Thanks, Graham, and thanks, Keaton. Helpful presentation. Just a quick question. We're talking about validated models. Presumably that means you're looking for test reports, correct?
Not necessarily. It's how that's going to look exactly, I haven't fully determined yet. But basically, it's going to be very similar to the requirements that ISO has right now. Again, this is pretty much caught up with all the 5 megawatt sites they ask for these models, so it's going to be very similar to that process.
Yeah, we're used to providing for the larger sites, anyways. I guess test reports, and there's often a way that they want to see it or a format for the test report. So I guess that's my open-ended question: is we're going to be looking for what validated means and what you want to see and what the back and forth is going to look like on that.
Yeah, no, definitely. again, I will get more information on that specific piece. It's just at this point the most pressing thing for us is those thresholds.
All right, thanks.
Yeah, that's good.
Go ahead, Dean. I see you have the question there. Go for it.
Dean, you'll need to unmute yourself first.
Yep, go ahead. You can unmute yourself now, Dean. Go ahead. Sorry if you couldn't hear me.
Okay, now I got it. Too many options.
I think he's muted again.
Okay, does this work now?
Yes, I can hear you, Dean.
Yep.
Okay, good. Yeah, just Signalta Resources, we have a whack of units that are fixed power factor, and there's no way of installing anything. The 60-day notice for legacy units means we'd have to try and find some boxes to wire into those things. So
yeah,
we really would be interested in knowing which of our units we're going to have to do something with. And that is going to require us to like buy hardware, wire it, commission it. So the 60-day notice is not really doable. So I hope there's going to be some consideration for delaying until we can actually meet some of the requirements.
Yeah, so I guess yeah, sorry, go ahead, keep going, Dean.
The other question I had is you're looking for O&M generator models. We've tried for a lot of our units to get O&M models, and they're like, yeah, they don't exist. So
yeah,
what's the path forward in those areas? Like
I said, the sync gens, we're not covering them quite yet in the EMT piece just yet. This was kind of like a heads up saying like we may need to do it in the future, but for now just the modeling parameters should be enough. But we're looking into what we would have to do if we were to require that, which is we're just not at that point just yet. If that makes sense. It was just more of a heads up that we may ask for this in the future. But we'll be doing a separate consult on that specifically if we do go down that path, and then that one will be kind of tied specifically through rotating machines, DERs that we deal with only in that case.
Okay. So you're not considering synchronous machines at all at this point? It's a
no, not right now. It's a future consideration, yeah.
Okay, thank you.
Yeah, for now it's just the modeling pieces themselves. So like like the sub-transient reactors, the transient reactors, most of the stuff that's already provided is what we're looking for. Yeah.
Thank you very much, Dean. Yeah, I've not seen too many further active hands. Nothing in the Q&A.
I guess what I've got as well, Graham, is I just realized as well that in the slides we don't have the actual rollout plan specifically for the Volt-Var. So maybe I'll just quickly speak to that. So phase 1 is going to happen for Volt-Var right away in Q1 2026. But that rollout is specifically related to the pilot. So the proponent that did the pilot project with us will be working directly with them pending their approval to get the other 2 sites that are nuisance tripping up and running. In tandem, we're going to run phase 2 as well, and phase 2 is nuisance tripping sites. So specifically, those sites are the ones that are having repeat problems with staying online, so they trip on overvoltage frequently. Those are part of phase 2. And phase 2, we are also targeting Q1, Q2, 2026. Phase 3 is weak feeders. And it's when we're talking about the weak feeders, these are more assigned by ISAR's report, like they've got a reliability roadmap that kind of talks about that. We'll be targeting those areas as well for phase 3. We're not going to start that till Q3 of 2027. Again, these timelines are all estimates at this point. And then the last phase will be everybody else. So, and that'll be phase 4, and we're not targeting that till 2028. It's like Q2 2028 is when we're targeting. If we can move things up, we will. But if we can't move them up, then it is what it is. But our intent is to hit phase 1 and 2 fairly quickly, and then kind of pause and wait for like 6 months or so, and just kind of see how the dust settles, and see if things are working out for us. And if we need to make any changes, then we'll make those changes before we start rolling into phase 3. So just to add a little bit of clarity on that as well.
Absolutely. So is it safe to say, Keaton, that the first 2 phases will very likely benefit those power plants because of that nuisance tripping effect that's happening?
Yeah, that would be a fair assessment. Is that the proponent from the pilot? We haven't actually spoken to them yet either, so that's why I'm adding that caveat. It's going to be from their approval.
Right.
If they want to be the first sites, but part of that first group of sites, then they will be. But if you are having nuisance tripping problems and you do want to be part of that phase 2, then we are asking that you provide that information to us to say that you would like to be part of that phase.
You can use that same email and subject there?
Yep.
To do that?
Yep, same email and subject. Yep.
Understood. Okay, we do have another participant here. Looks like Craig. Craig, I'll give you the mic here so you can unmute yourself. Go ahead.
Thank you, Graham. Just a quick follow-up question. So for my whole site, you and I have been talking about that a little bit. Does this Volt-Var pertain to that, and will that potentially help with the overvoltage trips?
Yep, that's the idea. Okay. Yeah, so how Volt-Var works is if the voltage gets too high, it will start to lower that voltage. So it'll absorb reactor power to drop it. And if the voltage is too low, what it'll do is it'll try and raise the voltage. So it'll inject reactor power to do it. But again, it's more dynamic than what you would normally see. So if you are tripping frequently on overvoltage, generally speaking, when you see this, you should start seeing that it will absorb reactor power based on what the voltage is doing. So, and the idea behind this is to get less nuisance trips on top of all the other benefits, which is more stable voltage and also the reduction in regulated tap operations.
Perfect. Okay, I understand. Thanks.
Thanks, Craig. Thank you. It's a lot of information. We're definitely going to be releasing the recording and subsequent bulletin, as Keaton mentioned at the beginning. Something to digest, bring back to the teams. Oh, Human. You two here, sir. Just give me 1 second. Oh, and just a reminder, as much as a lot of us know each other, small industry, but just first name and affiliation is always good, just so everyone knows who's talking. You should be able to unmute. Sorry, go for it, Human.
Hi, this is Human from Signalta. Just a quick question for you. As most of the generation units, the gensets, they are not certified. We heard that CAT is certified, is maybe the only one that they are certified. Please confirm if they are. Anyway, the other brands, to my knowledge, they are not certified. So it looks like we need to have IEEE 1547 certified reviewer to review our design to make sure that we comply with IEEE 1547. My question is, if we have them, if we have the certified IEEE reviewers, and if they sign the design, should we be concerned after that may Fortis review the things and they say, no, you don't comply? Or if we have our documents, our design signed by the reviewer, then it means we are good to go. Thank you.
Okay. Yeah, Herman, that one's outside the scope of this specific the specific webinar, but that's outlined in the DR2 D&E standards. But maybe send that question over to your stakeholder relations manager, and then we can answer that separately to this.
Graham, if you don't mind, this is the question that I have, and if you can direct this question to the right people, that would be fantastic.
Definitely. I was actually just messaging you right now. We'll form a question, and I'll put it in the task management and get that to the pertinent party for a response.
Thank you.
Just write that to you here. Thank you for the question.
And just a reminder as well, Q&A is open. So if you're not comfortable with coming off mute as well, feel free to type your question in as well. Okay. Are there any other questions at this time? Everything's perfectly clear.
I think we can stop at there's no further questions at the very least. Yeah. But yeah, I think the opportunity to digest the webinar, the slides, opportunity to send a bulletin. The bulletin's more of a notification that emphasizes the presentation. As I say that, actually, I can answer this one as far as, so we have one from Murray just asking, I'll publish it here, when the presentation recording is going to be posted. When do we want to do that, Keaton?
We are targeting basically Q1. A bunch of the information will be Q1 next year. The recording we'll get it up as soon as we possibly can.
Okay. Yeah. So presentation recording up as possibly can. So 2025 then, right? Yeah.
Yeah.
And we'll have the bulletin that corresponds with it formally on the website as well. Yeah, I've been watching that draft go around. Thanks for the question, Marie. Obviously, a very good one, just as far as getting the info to you and the teams.
Okay. Cool.
Okay, yeah. Excellent. If that's everything, again, just really appreciate the time this morning. Appreciate your patience with the new format. As you can see from the first few slides, FortisAlberta as a system operator is in a very unique position in how fast generation has penetrated the distribution system, and now we're in that phase where this is going to happen, I think, a lot more. And so any feedback on this format and how we can improve is always appreciated as well. There's a lot of learning all around, even from a technical position. Want to emphasize again how much we appreciate the time of everyone on the call. Time is a very precious thing in this industry, so I have to acknowledge that. And if that's nothing else, we'll leave the presentation and webinar here, and looking forward to the feedback and meeting with many of you in the next weeks and months to come on this and other things. Thank you so much again.